What is up, guys? Welcome back to the third episode of the CSpreneur. Today we'll be actually getting into the programming of things. So now that we've set up our EV3 and now that everything is set up with both the color sensor and the ultrasonic sensor set up, we are good to go. So let's go ahead and power on our EV3 and let's go ahead and follow along on the computer here. So as the EV3 is booting up, let me just discuss how you would get to the screen. So once you've installed the NXT EV3 software, you're going to open it up and you're actually going to see a bunch of robots. So from there, what you would do, let's see here. From there, what you would do, you click New Project, and that's how I've gotten to where I am. So project is just a container that holds a bunch of programs, just for your information. So the individual program, as you can see here, and that's the EV3 booting up, the individual program, as we see here, has this start block, and this start block is necessary for each program to succeed and actually run. So the start block, if you click this will actually execute the entire program on the EV3. And you can actually hear that, that beep going on right there, which indicates that the program has now been loaded onto the EV3. So moving on, I know this may look a little daunting. There's a bunch of logic blocks here and there's a bunch of moves blocks here, but I'm going to discuss what each one does. But before I go into the software side of things, let me just show you what's going on with the hardware side of things. Now, I know we discussed light ambiency and reflected light ambiency. If you guys don't remember that, that's fine. We're going to discuss it again right now. So notice on the bottom right corner of the screen, you can actually see, I'll just probably zoom into it in editing. As I move my hand closer, the light actually has something to bounce off of. So notice how that red is on my hand, and as I'm moving it closer, I'm actually giving it a greater surface area and greater contact to bounce something off of. As you can actually see here that it's even reaching 50 at some points. So this is actually what you'll be using for the duration of the course. Now in the NXT 2.0, it's a bit different, where the color sensor has 100 for reflected light ambiency when you actually see that the color sensor is detecting white, and if it's detecting black, it'll actually be closer to 0. Now, of course, it won't actually be totally 0 unless you actually cover up the color sensor, because there's ever so little amount of light on there. And let me actually pull up a picture of a robot here doing something that we call line following. And so what we see here is actually just the code, but here, this is a better picture of it just to show you what's going on. So right here, what the robot is actually doing, you can see, is this is also called reflected light intensity sometimes. But so what it's doing, it's shining down this light that we discussed over here onto a white strip, or white and black strip, and so it's just shining onto that edge over there, and we'll actually discuss the logic behind this a little further next time, or the time after that. But when it's on, completely on the white light, you're actually going to be reading high reflected light intensity, and when it's completely on the dark line, you're going to be getting a reflected light intensity of closer to 0. So let's also discuss what's going on with the ultrasonic sensor. Now I know I said briefly and I mentioned that it was, let's see here. So of course, make sure that nothing's obstructing the ultrasonic sensor as you are using it. And I know, so last time we discussed that it's actually giving the distance between it and a particular object. So right now it's actually bouncing off the roof. Whereas if I put my hand over it, you'll notice that it's actually significantly reducing the number just on port 2 until I actually bring it down to 0. And so that's when, and 100 is actually the largest that you can go on the EV3. Now obviously that's different for the NXT 2.0. So now let's actually get into the programming side of things. Let me just close this. So right here we have a media motor, and right off the bat you can actually see that we have a tooltip that happens whenever you hover the mouse over a specific object. So in this tooltip, what we see is that this block is the media motor. So let's click, left click and drag. And then you can actually just drop right next to that the start block. So we'll get into programming sensors a little later because that's actually a little more complicated. But let's just see what we have here. So we have a media motor block on port A, B, C, or D. And so this only has one port because you're only connecting the media motor to one port. So then we also have all of these options. So off, you're actually shutting off the motor. So essentially, if the motor's moving and you don't want it to coast, or you don't want it to just shut off and let it move on for longer because of the inertia that is gathered up with rotating for so long, then you actually physically shut it off. And so if I click here, you'll see that I only have an option for either coasting. So coasting is where the robot shuts off but it continues moving because it has that forward momentum, or I make the motor actually move back just a tad bit to make it stop right in where I want it to. So this is brake and this is coast. So we also have the on block, which is just on, so we're going to make the motor on for an unlimited period of time, and we'll discuss how to use this in upcoming videos. So we also have the power here. So this is full power. We typically don't want to use that because that's way too much power. So as you can see here, the default was 75, and we typically use somewhere around 50 if we're wanting to do precise maneuvers so that the robot doesn't jerk and then go off track or anything like that. And so we have let's see here. We have a power set to Z. We can actually even set the power value to a negative value, or just negative 100, indicating that we want the motor to move backwards from the forward rotation. So that's a little bit on these two options. Now we also have on for seconds, and as you can see, we already recognize the power module here. We also recognize the brake at end. And you can either set this to true or false. So if we wanted to brake, then that would be true, right? But if we wanted to coast, then that would be false, and it's very intuitive graphical user interface over here. We also have on for seconds. So on for seconds is we're going to keep it the motor on for a certain number of seconds. Now obviously we don't really want to use this in precise maneuvers because this is pretty, how do I say it, unstable or just unreliable at most times, because every EV3 brake is slightly different in the power it gives to the motor. So typically what we're actually wanting to do, we're wanting to go on for rotations or on for degrees. Now I'll start with on for rotations and you'll understand why in a bit. So we have on for one rotation, which means that the motor has to move one full circle. And can anyone tell me how many degrees that is? Well, if you said 360, you're right. So 360 degrees equals one rotation. Now, if we were going to do a very, very tiny movement, which unit would we want to use? Should we use rotations or should we use degrees? So if you said degrees, you're right again. 360 degrees, as you can see here, it auto-converts. 360 degrees is equal to one rotation. So the unit of a degree is so tiny that it takes 360 of those to move for one rotation. So typically in all settings, we want to use degrees more often than rotations, if that makes sense. So we also have a large motor, and I already pointed that out to you. A large motor looks something like this, it should look the exact same on the NXT 2.0 kit as well. The media motor does not come with the NXT 2.0 kit, but you'll understand why I'll talk to you that in just a second here. So the large motor is actually, as you can see, the exact same programming as the small motor. You can see that the ports do not change. It's all A, B, C, or D, and all of these settings are the exact same if you see here. So if you know how to program the media motor, then you automatically know how to program the large motor. So moving on, we have two blocks that can actually be used for programming multiple motors at the same time. And that's why you see here there are multiple ports that we can pick. So there's A, B, C, or D, and we can also pick the secondary port A, B, C, or D. And this is typically used in a setting where you want two motors to move at the same time, and that's typically found in a robot that looks like this even. So if you see here, or if you see here, what you see is that this robot is actually moving using two wheels, and you can see one motor over here, one medium motor over here, and one medium motor over here. And for all of those NXT 2.0 enthusiasts out there, this is an NXT 2.0 kit, if you were wondering. So again, you can see here, this is typically used these types of blocks are typically used in a robot that has 2 driving wheels that needs to move forward with using both. And we'll discuss the difference between these 2 motor blocks. So as you can see here, it says move steering in the tooltip. If you see here, it actually says move tank. So in the move tank block, typically you're either doing a simple task. You're either moving forward completely or you're moving backwards completely. And you can see that there are 2 places where I can give the power to. And so essentially what we can do complicated movements like either curve by giving more power to one motor, or even just turn in place by giving full throttle to one power and the negative of that full throttle to the other power. So plus 100, negative 100 would make it just spin in place, if that makes sense. And again, we also have the coast option, and we also have the brake option, and again, on for rotations, on for seconds, on for degrees. We're going to typically use degrees unless it's a very, very long distance, in which case we'd either use rotations or on. Never use on for seconds if you're trying to drive a robot. So move steering block, this actually gets more complex. And what you see here, we're going to treat both of the motors like they're literally on a car. So we're going to move forward, so we're going to press on that accelerator how much ever. And we can actually also give it a negative throttle, so we can go negative, which makes it go backwards. And as you can see over here, the arrows automatically change backwards. This can also be set to 0, as I discussed before. So again, do we want to move rotations or move for degrees? Let's say if we're turning in just a specific area. If you answer degrees, you're right. We're going to want to use degrees if we're turning in just a specific area, in a small area or in a small turn. So as you can see here, this is actually the steering portion of it. So treat this like I guess you could call it a steering wheel almost. So if you want to curve one way, then you would actually use this arrow to make that curve. And if you want to turn in place, like we had discussed before with the move tank block, then you can actually even turn in place. And you can see and adjust how much ever you're going to be turning, and that arrow actually shows you which direction the robot's going to be going in. So it's super convenient. Now display blocks can be just used for fun. You can use an image, you can use shapes that can be displayed on the screen on your NXT, and that's also available on the 2.0. You can also do cool sounds that you want, and these can also be used for something that we programmers call debugging. And what that means is, let's assume that your program is broken, and you know these 2 blocks are going to work. And imagine that these 2 blocks are the problem, but we don't know that. So we want to place this beep after these 2 blocks. So once we do that, the robot will beep, which means that we know the program works until here. But once I move it over here, this block is broken. So this block won't actually fully execute, and this won't actually be completed ever. So assume that we did something crazy, like we made this on instead of actually moving forward for a set number of degrees, then this block will never execute because the robot is stuck executing this block over here. So yeah, that's basically the gist of why we use volume. And this gets really fancy. You will really never use this. This is only for the EV3. We're just changing the brake status light to a certain color. So moving on to logic, we'll actually probably just cut the video here since it's getting a little long. We'll move on to logic in the next video, and I hope to see you there. Thank you guys very much for following the channel. If you guys want to subscribe, comment, let me know if you have any questions. Again, I'm going to leave my my information down in the description. Yeah, we'll see you in the next video. Thank you.